So I want to take the indefinite integral of the sine squared of x times the cosine squared of x dx. So to begin, I want to start off by saying we have a sine squared and cosine squared s. I'm going to turn this all into cosines so I can reduce these powers up here. Alright, get it all in just terms of cosine. So I know the sine of x, or sine squared x, equals 1 plus the cosine of x over 2. This is actually 1 minus, write this, 1 minus the cosine of x, 2x over 2. I know the cosine squared of x is equal to 1 plus the cosine of 2x over 2. So knowing these two important trigonometric identities, like we have been using in the last couple of videos, we can just substitute these in and bring down these powers and get it in terms of just cosines and additions and subtraction of specific integrals. So I'm going to rewrite this as the integral sine squared x as 1 minus cosine of 2x over 2 times 1 plus the cosine of 2x over 2 dx. Okay, so now I'm going to, these 2's I can just pull right out front. So I'm going to get a 1/4 the integral of 1 minus the cosine of 2x. That's 1 plus the cosine of 2x dx. Alright, now I'm going to redistribute all these, and we are going to get a cosine squared again, so we're going to have to end up resubbing back in. So we're going to get a 1/4 times the integral of 1 minus a cosine of 2x plus a cosine of 2x, and then minus a cosine squared of 2x. Okay. This did make it it looks like it made it more complicated, which it didn't. We're able to cancel these two out, so we're going to get a much more simpler integral out of this. So 1 minus cosine squared of 2x dx. So I'm going to resub back in for the cosine squared of x. So I get 1 plus cosine 2x over 2 back in this section right here. So I'm going to actually move this down a little bit so we have a little bit more room. Okay, so this is going to end up being 1/4 times the integral, the indefinite integral, of 1 dx minus all this entire integral of, let's see here, 1 minus cosine of 2x is going to be our x, so we're going to have 4x over 2 dx. Okay. I put this here so I remember to distribute, because sometimes, you can end up messing this up and you won't get the proper answer at the end. So I'm going to have the integral of 1 dx minus, we're going to have the integral of 1/2, so I can pull out a 1/2 dx plus, look at that, it's a plus. It's a cosine, so I gotta change it back to a plus 1/2 times the integral cosine of 4x. Notice I just pulled out a 1/2 because a 1/2 plus a cosine of 4x over 2 is going to give us 1 plus cosine of 4x over 2 dx. Okay, so now to simplify this even further, we're going to have 1/2 times x. Okay, so because the integral of 1 dx is just x, minus the integral of 1/2 x. Okay, plus, actually we're going to distribute that minus in there, minus 1/2 times So we have the cosine of 4x, we integrate upwards once, which gives us this. Remember, we divide by the derivative of the argument of the function. So we're going to get sine of 4x divided by the derivative of the argument, which is 4. So we're going to have 4 times 2 here. Alright, plus arbitrary constant, because we're finished taking integrals. Remember always to put that arbitrary constant in there, otherwise your math teacher will probably knock you off. So this equals, it's an x and a negative 1/2 x is going to be a 1/4. We'll distribute that in there too, times 1/2 x, because of x minus 1/2 x gives 1/2 x, minus, let's see, 1/4 times 1/2 times 1/4 again. This should give me 32 times the sine of 4x plus arbitrary constant. This simplifies to 1/8x minus 1/32, okay, times the sine of 4x plus our arbitrary constant c. And there you have it.